Here you go. This is the circuit I have used. So the inverting operational amplifier circuit is like this. So I am applying this input to this negative input terminal via this input resistor R1, and I ground the other input terminal, that is the non-inverting input terminal. And also I am taking fraction of the output and feeding back to this input terminal number 2 via this feedback resistor RF. So this feedback resistor value is 100 kilo ohms, and also this input resistor value is 20 kilo ohms. So now if you apply the formula, then you will see very simply the value which is going to be in the output.
Hello. Yeah, so now I will show you one demonstration of how to implement inverting operational amplifier in this Analog Discovery Studio hardware kit or lab kit. So you will find different cables inside the box. So I am taking these 6-pin cables and I am using these male type connectors. I am just inserting this uh, connector here, the female type. So now this is inside. So here you can see very clearly what are the things are available in this port. So here we have the plus 12 volt and plus 12 volt and minus 12 volt, and we have the ground, and we have the V plus and V minus. We will not use the V plus and V minus. We will not use one ground. We are going to use only this plus 12 volt and minus 12 volt and one ground for this circuit. So now let us start the experiment. So now I am connecting this cable. So here also you can see a small projection, so this cable can only fit through this way. So now I connected this cable, and also there are several other cables I have connected. As I told you, here we have the oscilloscope. The oscilloscope is helping us to measure and display the waveform, input and output waveforms, or you can also check the waveform at different locations. And this is the function generator or waveform generator. So this waveform generator can generate waveforms at a specific voltage, and you can apply as an input to the circuit. So this is what I'm going to use. So for example, here for the function generator I use this black and yellow cable. So the yellow is the signal cable and the black is the ground. So I am connecting this cable here in this function generator, and then the blue cable you can see, this is for oscilloscope. For example, I can use this for input or output. So in this blue cable you can see one cable is with a small white color stripe. You can see here small white color line is going here. So this is the ground, and the other cable which is a complete blue, that is the signal cable. So you can also insert in this oscilloscope. It's easy, just plug it inside. And another cable is orange one, same like the blue. This orange one also having two different types. So one cable is with a white color line and another one is just without white color line. So without white color, complete orange is a signal line, and this one is the ground. So you also insert this in the oscilloscope, and now we are ready to make the connection in, or we are ready to build the circuit. Okay, so here you can see what I have here is IC741. So IC741, we know there are only 8 pins. So you have to know how to count the pin number correctly, or how to identify the pin numbers. So here you can see a small black color dot. So this black color dot will help you to start. This is the pin number 1 2 3 4 5 6 7 8. So I am going to connect this IC in this breadboard like this way. I cannot connect the IC this way because I will short all the pins. So I have to only connect this way. So if I connect like this, then so I already told you in my previous video, the horizontal lines are connected or shorted like this horizontally, and this inside these lines are shorted vertically. So I am just connecting the IC like this. I already connected the IC here. IC741 is connected in the breadboard. It's very easy. Just you put here the pin into the correct holes and then just press it. That's all. And I have two resistors. The blue color one, that is the input resistor, and the brown color one, that is the feedback resistor. So if you look at the circuit of the inverting amplifier, the input resistor is going to pin number 2, right? This is the inverting operational amplifier. So the one end of the resistor is going to the pin number 2. So in the IC you have to know the pin numbers. So this is 1, pin number 1, 2, 3, 4, and then 5 starting from the bottom, 5, 6, 7, 8. Okay, so the input resistor is connected one end to the pin number 2 and the other end is just connected separately. So here we are going to apply the input. And also the pin number 2 is having the feedback resistor, one end of the feedback resistor, and the other end is connected to pin number 6, that is the output. Please refer the circuit, inverting operational amplifier circuit. So now what I have to do is I have to give the input signal from the waveform generator to this resistor, the end of this end of the resistor, and the other end of the waveform generator, that is the ground, it should go to the ground. So now that's what I'm going to do. I already told you here, this yellow color is the signal and the black color is the ground. So I connect this yellow color to this resistor, and then this black color is going to the ground. I am going to make the ground here somewhere. Okay, so now I finished the input. Now I need to give the V plus V minus, that is the plus VSAT and minus VSAT. So according to our so here I have already showed you, this is the plus 12 volt and minus 12 volt. So I am taking the plus 12 volt, that is nothing but the red color cable. So plus 12 volt should go to pin number 7. So 1 2 3 4 5 6 7. So this is the pin number 7, right? So I put this plus VSAT or plus 12 volt to pin number 7, and then the minus 12 volt I am going to give it to pin number 4. Pin number 4 is just here. It's very easy. Pin number 4 is just here. Okay, so now we are kind of okay. And also remember, we need to ground the non-inverting input terminal, that is the plus, pin number 3. So the ground, I told you here we have also the ground. So the ground, for example, that is the black color cable, that is the ground. So the other two cables we have no use, so I am just taking away outside. And now I am putting the pin, this ground, to pin number 3. Where is the pin number 3? Here is the pin number 3, right? So I am just inserting this to pin number 3. And the other ground I am going to give it here. So here is the common ground. Whatever the ground, all the grounds I am going to connect here. So now the circuit is completed. So I had given the input, and also I had given this plus VSAT and minus VSAT. So now what I have to do, now I still have this oscilloscope. Oscilloscope, now I have this blue color oscilloscope and then the orange color oscilloscope. So the orange color, maybe I can use it for the output, and blue color I can use it for input, or other way. So now the orange color have two, one is the signal, one is the ground. The white line, the orange with the white line is the ground. So I am going to connect this to the ground, the same common grounds where I am connecting. And the other orange, for example, if I want to measure the output waveform, then I have to connect this in the pin number 6. So what is the pin number 6? This is the pin number 5 and 6. So 6 is, for example, I already have the resistor, so I am connecting just over there. So now I can also measure the input waveform. So where I am giving the input, I am giving the input in pin number 2, right? This resistor. So where the function generator is giving the input, so I am putting this parallel to this one. So now it means the oscilloscope is connected to the input side. The other ground pin you have to connect to the common ground. So all the grounds are here. So now you can see all the 4 grounds here, and we have completed the connection. That's all how to build this inverting operation amplifier. And remember, this kit also have the switch in the side. So this cable, actually this kit have 2 cables. The one is this one you have to connect here, and this the other side of this cable is going to the your laptop to USB port, and this one is the power in power supply to this kit. So you connect this one to this kit. The other end of the adapter should be connected to your stick contact or the plug point. Okay, so that's all. Now we completed, and before you after you connect this to your PC, you must turn on this switch, and then you are ready to start the experiment. And in your PC you have to open the waveforms software that I already asked you to install. Then I will explain how you can use the waveform, the software tool, by together with this hardware kit.
I have already set up the circuit under test on Analog Discovery Studio Lab kit. So, and also I have connected the hardware kit to my laptop through the given cable. Of course, I have to connect in the USB port. So now I am ready to work on this user interface. So this user interface, I can use it to see the input which I am applying to the circuit under test, and also I can see the output of the circuit under test in this display. For example, here there are so many options you can use, but at least for simple experiments for bachelor degree students, so we will just use this oscilloscope. Simply they put as the shortcut scope, and also the waveform generator. The other name of the waveform generator is function generator. So that we had seen already in the previous lecture or the video. I mentioned about the scope, what is the use of the scope, oscilloscope, and what is the use of the function generator. So now once you open these waveforms, it will show the interface like this. So it will take you to this welcome page. In this welcome page you can see all kind of icons and different functions of this software. So right now for our experiment we just need only scope and wave generator. So first click the wave generator. So the wave generator is very important because this is going to generate different shape of the waves. So whatever the shape you want, you can generate. For example, if you click the type, so you have so many options which whatever the wave you want, you can just select. For example, I need just only sinusoidal wave, so I select sine here, and then you can set up the frequency. I set up 1 kilohertz. This is the default value. I just keep as it is. If I want to change to 2 kilohertz or 5 kilohertz or 10 kilohertz, I can change, so according to the experiment. And also you can change the period, that is the x-axis. This also I keep as a 1 millisecond. And amplitude, this is important. So here you can change the amplitude value. For example, here I have 2 volt, so I can change to whatever the value. For example, now I change to 1 volt. So you can see here now I got just only 1 volt. So you can see the division here, the vertical division. So here 0.5, so one division is equal to 0.5 volt. So here we have 1 2, we have 2 divisions for this wave, so it's 1 volt. So this 1 volt is for the positive cycle and 1 volt is for the negative cycle. So totally this is 2 volt we are applying as the input. So now we are already prepared the input from this waveform generator. Now you can check at the oscilloscope how it looks. And remember, once you set up this kind of input waveform, which you are going to apply to the circuit under test, before you go to the, if you want to see the result, you must run. For example, here I am going to run. So now this waveform is running and this input is applying to this circuit under test. So now I just click go back to the welcome and then I click the scope or oscilloscope. So in the oscilloscope, you can see here very clearly, I have two channels. So here channel 1 and channel 2. So the channel 1 is input, that is yellow color. So you remember how many the whatever the voltage we applied, that you can see here, and the output is the blue color. So for example, the circuit under test I have built in this analog discovery studio for our experiment here, or at least for our demonstration here, is inverting operational amplifier. So inverting operational amplifier will always amplify whatever the signal you are giving at the input terminal, but it will also do inversion of 180-degree. So here you can see the input is going towards up like this, and then the output is blue color. So the blue color is just going in the opposite. So there is a 180-degree phase difference because this is inverting operational amplifier. You are applying the input to the negative input terminal. So you remember what is the voltage value we set for the input voltage or the input signal. Let us just go back to our wave generator. Here you can see the shortcut. So just go to the wave generator. We set the amplitude as 1 volt. 1 volt is for the positive and 1 volt is for the negative cycle. So totally 2 volts. So here when you go to the scope, you can see something little bit different. I am also running this one. So now what is the voltage you have now? So previously I set different values. Of course, now after I start to run, so this waveform is running lively from the wave generator to the circuit. So now you can see this positive half cycle is 1 volt. You can see the vertical. This each section is equal to 2 volts. So the positive half cycle 1 volt and negative half cycle is 1 volt. So totally 2 volt. So I am applying 2 volt. And what is the output I am getting? So, and also remember, I used the value feedback resistor as 100 kilo ohms, input resistor as 20 kilo ohms. So use the formula, very simple formula, and you can easily calculate the output voltage. So here let us see what is the output voltage. So here we have the 2 plus 2 plus 1. So the 5 volt in the upper cycle and 5 volt 2 plus 2 plus 1, that is 5. So 5 plus 5 totally 10 volt. So we are getting 10 volt at the output. So we are applying only 2 volt to the operational amplifier sinusoidal wave. At the output we are getting 10 volt, but which is also having 180-degree phase difference. So you should I have a separate video where I have explained how we can derive the formula for output of inverting operational amplifier. Just for our knowledge, just I will show you a little bit now. So for example, if you derive the formula, then the formula will be like this. So V out is equal to minus RF divided by R1 times V in. So here V in is 2 volt. So RF is 100 kilo ohms, R1 is 20 kilo ohms. So 100 divided by 20 is going to be just 5. So 2 times 5 is going to be 10 volt. So this is what we are getting as the output from this oscilloscope. So oscilloscope is helping us to measure, first of all, it helps to display the waveform at the output terminal, and also it helps us to measure the value. So display and measure, that is the function of the oscilloscope. So now you can see here, so this is the division 1, division 2. So this is full, and this one, the third division is only half. So we have 5 volt in the negative cycle and 5 volt in the positive cycle. 2 plus 2 plus 1 5. So totally we have 10 volt.